Question 4 is a circle geometry question, and it's quite unusual in the sense that you don't even have a numeric value in the diagram. You can see you have t, y, and y. In a usual question, like in previous years, they'll give you a numeric value like 40 degrees here or 30 degrees here or something. But here you're not giving, you're just giving letters for values. So let's read and understand. In the diagram, ABC is a circle with center O. This is ABC, this is circle with center O. The quadrilateral OBCD is a rhombus. Now this is a rhombus. You have O to B to C to D. And note that in circle geometry, you might not be very sure of your destination or how you're going to achieve it, but you should just keep taking the notes of things that you see that are very important. The quadrilateral OBCD is a rhombus. Now we know it's a rhombus. That means a rhombus has all sides equal, just like a square, but it's slanty or it's at an angle different from 90. That means this, and this are equal. And also note that the distance from O to B is the radius, and also O to Y is also the radius. That means if this is a radius, this is also a radius, and the length of this is also radius, and this length of this is also radius. Let's just put that in mind. So in circle geometry, you have to just note all important points. It's a rhombus such that ADO, that's the angle at D to A and to O, this D to A and to O equals angle OBA at B to O and to A, both equals Y. You can see they've indicated both of them are Y. And angle BAD at A you have BD is T. This is T. Find the value of T for the first question, then find the value of Y for the second question, then C. Find angle ADC, that's at D. You find angle A to C, that's this big angle. So let's take it one at a time. Note that I've solved this question before, but I'm trying to explain in a way that you can understand, and in moments where you see these kind of questions, you'll be able to try and attempt to solve them. Or these kind of questions are the questions you might leave for later. You solve the easier ones first, or seemingly straight questions first, then come back to them. Now note that if this is T, this is 2T. That is BOD, that at O, this angle is equals to 2T. Noting that angle formed at the center is twice angle formed on the circumference. That means if you look at the two angles from the lines that form both of them are from the same point. You can say they are from the same ends. Like this is one end at B, this is going up to meet at the circumference, these two, and the one at the center too. We know the theorem in circle geometry that says angle at the center is twice angle at the circumference. Center equals 2 circumference. We know this angle is 2T. What else can we figure out? We know this is 2T, and remember they said this is a rhombus, and opposite angles in a rhombus are the same. So if this is 2T, this is also 2T. So we have at angle C, B to D is also 2T, because opposite angles of a rhombus are equal. This is also 2T. Now that we know this is 2T and this is 2T, we'll think of things we can figure out. We know this question is quite technical, or let me say very technical, so you have to have a good knowledge of all the theorems or laws in circle geometry for you to figure out this question. And note that you're not working with a numeric value, so it will be quite hard for you to figure it out if you're not used to it. So we know this is 2T. This angle out here that's going around O on the other side will be 2T times 2, using the same principle of the angle formed at the center of a circle is twice the angle formed at the circumference. If you understand your circle geometry well, it's not only when you have it in this shape, but also says when you have something like this, like a rhombus or something like this, one is from center and one is on the circumference. That means this angle outside here is twice what is inside here. So if this is 2T, this will be 2T times 2. So angle O, we can say, equals 2T times 2. That angle at the center is twice angle at the circumference of a circle. So our angle O is 2 times T is 4T. This upper angle is therefore 4T. Now we know, if you look closely at this, we know this is a circle, that's angle at a point. So that means 2t plus 4t should equal 360. So we have that 2t plus 4t equals 360 degrees. That's angle at a point. Then 2t plus 4t is 60 equals 360. Since we're looking for t, we divide both sides by 60. T equals 60 degrees. For question B, we are asked to find the value of y, and we're asked to find angle y. There are at least two ways of solving this question. Let's take the seemingly easier route first. We know t is 60 degrees, and from what we've discussed earlier, we know this angle here is 120 degrees. That angle formed at the center is twice angle formed on the circumference of a circle. And as you can see, 4 lines that form the angles, like the two that forms the angle at the center, are from the same ends as the ones that form the angle on the circumference. So this is 120 degrees. Now noting that this line and this line, that line OB is equals to line OD, that this line is equals to this, because from the center of the circle to the circumference is the radius. So this is the radius and this is radius, and we know this is 120. That means this angle and this angle are the same. That's like base radius of an isosceles triangle, because these two equal lines make this triangle an isosceles triangle where the base angles are equal. We have this to be 120, so we can say this angle is A and this is also A. So we use this triangle, that's OBD, to find the value for our A and therefore find the value for our Y. If you're fortunate enough to spot this first, you'll be able to use it to solve this question rather than go through the rhombus to solve this question. So we have it as A plus 120 degrees equals 180. That's sum of angles in a triangle. So we have A plus A is 2A plus 120 degrees equals 180 degrees. Since we're looking for the value of A, 2A equals 180 minus 120 degrees. Take out the plus 120 over the equals sign, it becomes minus 120. We have 2A equals 180 minus 120 is 60 degrees. Since we're looking for A, we divide both sides by 2. 2 cancels 2, 2 here 1, 2 in 60 is 30. So we have A equals 30 degrees. Now that we know our A is 30 degrees, A is 30 degrees and this is also 30 degrees. Once we've gotten the value of our A to be 30 degrees, we can now find the value for our Y, taking into consideration the triangle ABD as this big triangle, where you have A and Y and A and Y here. That means this is at least an isosceles triangle. That means at least 2 sides are equal. We're not sure if the third one is the same until we calculate. I know this is 60. So we use that to solve the question. So let's redraw the triangle so we understand what we're doing. So we have a big triangle. We have A, B, D. We are sure we know our A is 60 degrees. Then we have this as Y plus A, and we know our A is 30. This is Y plus 30 and this is Y plus 30. So we have this as Y plus 30 since we've calculated our A to be 30. And on this side we have Y plus 32, similar to this one. So we take it as 60 degrees plus Y plus 30 degrees plus Y plus 30 or 30 degrees equals 180. This is a triangle. We have to have sum of angles in a triangle, which is equals to 180. Collect like terms, you have Y plus 60 plus 30 plus 30 equals 180 degrees. That means we take the Y's first. We take 60, we take 30, and we take 30 equals 180. Y plus Y, 1Y plus 1Y is 2Y plus, now we have 60 plus 30, that's 90, plus 30, that's 120. We have this as 120 equals 180. We're looking for Y. We have 2Y equals 180 minus 120. We take out the plus 120 over the equals sign, it turns to minus 120. We have 2Y equals 180 minus 120 is 60 degrees. We divide both sides by 2. Since we're looking for our Y, 2 cancels 2. Y equals 2 here 1, 2 here 30. we have this as 30 degrees. So our y is 30 degrees. We know t is 60 degrees, and we know this angle is 120 degrees. Let's say we have this as a rhombus. That means all sides are equal. We know if this is 120, this is also 120. So this is 120 degrees. Now if this is 120 and this is 120, and this angle, let's say this angle is x, and this is also x, because opposite angles of a rhombus are equal if you know the properties of a rhombus. Now we know this, we can now say, since a rhombus is a quadrilateral with 4 sides, and the sum of interior angles of a quadrilateral including a rhombus is 360, so we know x plus 120 plus 120 equals 360. So we have x plus 120 plus 120 equals 360. That's sum of angles in the quadrilateral. Find x plus x is 2x. 120 plus 120 is 240 equals 360. Since we're looking for x, we take out 240. You have 2x equals 360 plus 240 crosses equals sign. It can turn to minus 240. So we have 2x equals 360 minus 240 gives us 120. So since we're looking for x, we divide both sides by 2. Our x equals 60 degrees. So we know this total angle is 60 degrees. Now knowing that this total angle is 60 degrees and this is a rhombus, this line that you see, this dotted line, divides this angle into 2 equal parts. And same as this is a rhombus, from this point in a rhombus to this point, divides it into 2 equal parts. Then if this total angle is 60, then this half is 30 degrees. Now we know this half to be 30 and this half to be 30 degrees. Since we know both halves are 30 degrees, and we have this triangle, we should note this triangle. See this dotted line, that's B to D to A. This is a triangle we're working with, ABD. Work with this triangle. We have something like this. We have this line in the middle. We have this part to be y and this part to be 30. This part to be y and this part to be 30. And we have this part to be 60. Looking at the diagram here, on this side, y and 30 makes this angle. So this is y plus 30, and 60. So all of them should equal to 180 because the sum of angles in a triangle is 180. So we have y plus 30 plus y plus 30 plus 60 equals 180. We can collect like terms. Y plus 30 plus 30 plus 60 equals 180. Y plus y, that's 1y plus 1y is 2y, plus 30 plus 30 is 60. 60 plus 60 is 120 equals 180. We're looking for y. We have 2y equals 180. We take out this plus 120 outside, it becomes minus 120. We have 2y equals 180 minus 120 is 60. Since we're looking for y, we divide both sides by 2. That we divide both sides by the coefficient of y. The coefficient of y means the number in front of y. These 2 cancels 2. Y equals 2 here 1, 2 here 30. Y is 30 degrees. Another method for looking for y will be explained next. A third and final method of finding the value of y, that's for 1b, is to use the shape ABOD. That's a quadrilateral. Look at it. To find y. And you know the sum of interior angles of a quadrilateral sum up to 360. So we have, this is the first angle, this is the second angle, this is the third angle, and the fourth one is this, which is like this. And we know this is 60 degrees, and we know this is 120 degrees, and from this 120 we can find this external angle. We know this is angle at a point, so we can do 360 minus 120 will give us this angle. If we can also remember while solving question A, that's the value of t, we noted that this external angle at O is 40. Since our t is 60, we can also do 4 times 60 because it's also 40. Even actually 3 ways we can find it. We can even find it from this. We know this is 120. I know this is angle formed at the circumference, and for you to find the angle formed at the center, you need to multiply 2 by the angle formed on the circumference. We've done this before. You know this is 120, this is also 120, and this will be times 2 of this, so this will be 240. So we know this is 240, and this is just to prove to us that there are several ways in solving certain questions, particularly when it comes to circle geometry. So we know this is 120 and this will be 240. Now even if we take this as 120 and we're saying angle at the point is 360, if we do 360 minus 120, it will still give us 240 degrees. So in any of the 3 ways, we still get that this is 240 degrees. And now that we know this is 240 degrees, this is 60 degrees, and we have our 2 y's here. That means 240 plus 60 plus y plus y should equal 360. Let's draw the shape again so we can understand. The thing about circle geometry is being able to spot shapes in shapes, particularly shapes required to solve a particular question. So we have this now out. Now I've separated the shape from this total diagram. We can now solve for y. See, y plus 60 plus 240 equals 360. That's sum of angles of a quadrilateral. Y plus y is 2y plus 60 plus 240 is 300 equals 360. 2y equals 360 minus 300. We take out the plus 300 over the equals sign and becomes minus 300. We have 2y equals 360 minus 300 will give us 60. Now we're looking for y, and we have to divide both sides by the coefficient of y, which is 2. We divide both sides by 2. 2 cancels to 2 here, 1, 2 here, 30. Y is 30 degrees. So looking at this, we have actually seen there are 3 ways to get the value for y, which is 30 degrees. And the thing about solving with these 3 methods is to show you that there are actually 3 different ways, or at least 3 different ways of solving this question. So whichever one you're comfortable with, or whichever one comes to your head when you're in an exam, or you should apply it, provided it follows the rules or the guidelines of that particular topic in math. For the third question, we are asked to find angle ADC. Note that we are looking for this big angle, and we know this angle y is 30 degrees, and we figure out that this angle here, that's angle D in the middle to CO, at this angle is 60 degrees. Then we can now add the 2 angles together to get the total angle, that's from angle at D, A to C. That's this big angle is therefore the addition of this angle and this angle. This is 30 degrees, and we figured out that this is 60 degrees. So we have this as 60 degrees. So the total angle will be angle at D, CO plus angle at D, AO. That's the addition of the 2 angles. That's 60 plus 30. Angle ADC is therefore 90 degrees, which is our final answer.